I recorded almost this entire lesson and realized that I had mean and median mixed up. So here I am starting over again. Good day, sunshine. This is Centers of Distributions, Unit 5, Lesson 3. Let's do a quick review. And hey, don't be like me. Get this right. Mean is the one where you have to do math. It's mean. They're being mean to you. You have to add all the values together and then divide by the number of values. Median is the easy one. You just arrange the values in ascending order and find the middle value. If there are two middle values, like you have an even number of numbers, then you add the two middle numbers together and divide that answer by 2. Okay, we're going to start with symmetrical data sets. They occur when the mean and median are the same, and the dot plot will appear symmetrical because one side of the graph is a reflection of the other. So for example, this is a symmetrical data set. If you folded this in half right on that 2 line, then everything would line up. You can see that you'd have 1 dot on both 0 and 4. You'd have 2 dots on 1 and 3. Okay, it's just like if you're cutting a heart out of paper and you can fold the paper in half and cut out half a heart, and then you have a perfect symmetrical heart. Okay, same idea. So the first step is to find the median by checking the number in the center of the data. Since we have 9 data points, the median will be the 5th number. The data in order are, and they give you the list, and so I'm on here, I showed you how I figure it out. So ever since I was in elementary, I've always just taken first and last number, then the next two, then the next two, then the next two, till 1 number's left. So here you can see that the median is 2. Okay, I will show you how they're doing it in a minute. So the 5th number, 2, is the median. So for this graph, the median is 2. Now we're going to figure out the mean. Mean is mean. They're being a bully. They're making us do math. To find the mean, you add all of the values together and then divide by the number of addends. So we're going to add 0, 1, 1, 2, 2, 2, 3, 3, 4, which is written right here, and then divide by how many dots we have, which in this case is 9. Okay, if you add all of these together, which I did with my calculator, you get 18. 18 divided by 9 is 2. So our mean is 2, which is the hard math number we have to work at it. The median was also 2. So when these two numbers are the same, then you have a symmetrical dot plot. Okay, we can see that it's symmetrical here. The math verifies that it's symmetrical. All right. Here is example number 2. So the first step is to find the median, which is the easy number, by checking the number in the center of the data. So we have 15 data points here. So to find the middle, if we did 15 divided by 2, that's going to give us 7.5. Now obviously there's not a dot, a 7.5 dot, right? Because the dots are whole. So what you have to do is you have to go 1, 2, 3, 4, 5, 6, 7. We want the dot that's right there, but it doesn't exist, so we're going to go to this next one. That's how they're finding the middle point. So if this makes more sense to you than crossing out, each number, that's how they're doing it. Okay, so this says that our median is 8. Okay, either way you can do it. Our median is 8. So now to find the mean, we need to add all of these values together. So it's 5 plus 6 plus 6 plus 7 plus 7 plus 7 plus 8 plus 8 plus 8 plus 9 plus 9 plus 9 plus 10 plus 10 plus 11 divided by however many dots there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15. Okay? And when you divide those, you find out that the mean is also 8. So we can see, looking at this dot plot, that it's symmetrical. The outside numbers both have 1, the next ones both have 2, and then we have 3, and then we have our center or fold point. We can see that it's symmetrical. The math checks out that it's symmetrical. Okay? Now, if you don't want to sit there and go 5 plus 6 plus 6 plus 7 plus 7 plus 7, okay, you could also go 5 plus, we have 2 6's, so it would be 2 times 6, okay? This is only if this is the way your brain works. If it doesn't, don't worry about this. Plus 3 7's, okay? plus 3, we have 3 dots at 8, okay, plus 3 9s. I'm going to have to change my color here so you can continue to see me writing, okay, plus 2 10s, plus 11. So if you're more algebra minded and you like this kind of stuff, this is another way to add them all together, whichever way your brain prefers. I am very basic and very simple, and I prefer to get my calculator and go 5 plus 6 plus 6 plus 7 plus 7 plus 7, okay? But you would just go through like you were doing your normal algebra, and this would become 12, and this would become 21, and this would become 24, this would become 27, this would become 20, and you would continue going through and adding them all together, okay? Just whichever way works best for your brain. So we find that both the mean and the median are 8. They are the same, which means that this is a symmetrical distribution, okay? Here is example number 3. Use the dot plots, which has the greater center. So first notice that both data sets are symmetrical. Just because all we've seen are these beautiful like mountain looking things that are symmetrical doesn't mean this one's not. On the outsides we have 2 points, next we have 1 point, and then we have our fold point. These are still symmetrical. If we fold this in half, it's still going to match, okay? These are both symmetrical, you can tell by looking. Okay, both the mean and the median will have the same value with each data set. So find the median first because it's easiest. You can just find the middle value, right? So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, that means that we need to do 9 divided by 2 is 4.5, okay? 4.5, or you can just cross off the dots, whatever works easiest for you. So we have 1, 2, 3, 4, and we want the one right here, but we can't have it, so we go to the next one. So this median is 7, because we can look at it and see that it's symmetrical. We know that the mean is also going to be 7. Do the same thing down here, but this has an even number of data points. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Half of 12 is 6, so we go 1, 2, 3, 4, 5, 6, but we have to take the next one too. In this case, they're both 8, so our mean is 8. So if this one has 7 and this one has 8, this one has the greater center. And you can see that looking here. All of these points on the number lines line up. You can see that the center is here for this one and it's here for this one. So this one has a greater value for the center. Okay? That's what all of these slides say. Okay? Here's question 1. This is your turn to solve. Compare the mean and median of the dot plot. Go ahead and pause the video and do that, and then come back. Okay, we can see that this is symmetrical, so we only need to find one of these values. The median is easiest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 divided by 2 gives us 7. Okay, because we have an even number, we're going to have to take 2 data points, 1, 2, 3, 4, 5, 6, 7, this one and the next one, which means that our mean and median are both going to be 74. Okay, because it is symmetrical, they're going to be the same. That's all you need. Okay, the median is 74, the mean is 74, the dot plot is a symmetrical data set. Here's question 2. Compare the mean and median of the dot plot. Go ahead and pause the video, figure it out, come back. Again, we can see this is symmetrical. We have 1, 1, 2, 2, 4, 4, and our fold point. Okay, so we only need to find one. Median is easiest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 divided by 2 is going to give us 9.5. Okay, so let's find that data point. 1, 2, 3, 4, 5, 6, 7, 8, 9. We want the one right here. We can't have it, so we'll take this one, which means that the median is 3. Because this is symmetrical, the mean is also going to be 3. Okay, Pachink. Here is question number 3. Which dot plot has the lesser center, and how do you pause it, figure it out, come back? All right, so what we need to do is find Are they symmetrical? This one is. This one is. So we only need to find one. Let's go with the median because it's the easiest. 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4. 1, 2, 3, 4. Even number. Got to take 2 dots. Okay. So this one is going to have a value of 2 for both the median and the mean. This one, 1, 2, 3, 4, 5, 6, 7, 8. Half is 4. 1, 2, 3, 4. Even number. So we got to take 2 dots. This one is going to have a value of 3 for the median and the mean. So which one has the lesser center? Chunk, 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 chunk. And we know that because we did the math and this has a center of 2. We can also look at it and see that most of the dots are following at 2 here, while the center here is at 3. Okay? All right, now we're going to move on to the question. We're going to move on to the questions at the end of the lesson, so just write your answer down for now, and then when you finish the lesson, you can go ahead and enter your answers in. Practice question number 1 says, compare the mean and median. Is the data symmetrical? So pause the video, figure it out, and then come back. So first of all, we can just look at this and see that the data is not symmetrical because we have 1 point, 1 point, 2 points, 3 points. So your answer is no. I will also show you how to verify this with math, even though you really don't need to. You can just skip to the next slide if you don't want to deal with this. Median is easiest. Let's do that first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 divided by 2 gives us 5.5. 1, 2, 3, 4, 5. We want right here. We can't have it, so we'll take that one, which means the median is 1. Now we've got to do the mean, which is mean and bullying in math. So we have -1 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 3 gives us 12. And that's going to be divided by how many dots we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 divided by 11 gives us a big long number that's basically 1.09. So the math verifies these are not the same number. This is not a symmetrical graph. Okay. Here's quick check question number 1. I will not give you the answers to the quick checks, but I will tell you how to find them. So compare the values and calculate the median of the given data. Given, not given. So the median is the easy one. You're just going to find the middle number. So you're going to count how many dots there are, divide it in 2 and find that number, or you can just go through and you can go get rid of 1, get rid of 1, get rid of 1, get rid of 1, whichever way your brain works better. All right, just find that center number. I believe in you. Okay, we're going to talk about skewed data now. When there are more data points on one side of the graph than the other, so when the graph is not symmetrical, on a dot plot this will appear as more dots on one end of the graph and a tail of dots on the other end. Okay, so the way I refer to it as the graph will look like it has a head and then a tail, like a dinosaur. Okay, like you have his head and then his tail coming off over here. So left skewed data, most of the data points are on the higher end of the range on the right side of the graph, and a long tail extends to the left. So if you're trying to decide if it's left skewed data or right skewed data, it's where the tail is. The tail is what matters. They want to know where's the tail. Okay, right skewed data, most of the data points are on the lower end of the range on the left side of the graph, and a long tail extends to the right. So where's the tail? It's on the right, so it's right skewed data. Here is example number 1. The number of students, this is where everything started to derail for me. The number of students absent from school was tracked over 13 days and displayed in the dot plot. Compare the median and the mean of the data. The first step is to find the median. In this dot plot, we have 13 data points. Since 13 is odd, the center will be the 7th number because 13 divided by 2 is 6.5. So we go 1, 2, 3, 4, 5, 6. We want right here, we can't have it. So our median is going to be 1. Okay, the median of this data is 1. Next, we're going to find the mean. How we do that is we add all of these together and divide by 13. It tells us how many dot points we have. So I'm going to grab my calculator, and I can skip all the zeros because 0 plus 0 is 0. We're going to go 1 plus 1 plus 1 plus 2 2, 3, 4, 4, 5. That gives us 23 divided by 13 gives us 1.769. So we're going to go 1.8 because it never tells us where to round to. Okay. So the mean of this data is 1.77, which we had 1769, so that's also correct. As you found, the median is 1 and the mean is 2. Then they rounded it some more because they never tell you what to do. While they're close, they are not the same as they would be in a symmetrical data set. The mean in this data is greater than the median because of data points like 4 and 5. Okay, these ones are skewing the data this way. They're pulling the mean this way. Okay. These points pull the mean further to the right than it would be if the data set was symmetric. The data set is right skewed because we have our dinosaur's head and then his tail. Okay, the tail is on the right. Here's example number 2. Ignore all of my wrongness. Use the dot plot to compare median and mean. Round to the nearest tenth. The first step is to find the median. Since there are 12 data points, you have to find the mean of the 6th and 7th point. 12 divided by 2 is 6. 1, 2, 3, 4, 5, 6. So we take the 6th and the next one because we have an even number. So we do 90 plus 95 divided by 2. 90 plus 95 is 185 divided by 2 gives us 92.5. So our median for this dot plot is 92.5. All right. Ignore all of my mistakes. When you round to the nearest tenth, the mean is 91.7. Okay, so they added all this together and already found the mean. Let's do that. So we have 75 plus 80 plus 85 plus 90 plus 90 plus 90 plus 95, 95, 100, 100, 100, 100. That gives us 1100 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1100 divided by 12 gives us 91.7. Okay. It told us to round to the 10th for once. Okay, that's right here. Since the median is 92.5 and the mean is 91.7, we can see that the mean is lower than the median. In data skewed left, the few data points that are a lot lower than the others will pull the mean lower than it would be if the data set was symmetric. These numbers right here are screwing with the whole rest of the data. This is not indicative of what most of the class is scoring. Okay. If in data sets skewed left, in which more of the points are higher values, the mean will be lower than the median. In data sets skewed right, the mean will be higher than the median. Okay, so the tail is over here on the left and the head is on the right. So this little bit right down here, I think you need it later in the quick check. But you know, I made this a week ago, so I'm not entirely sure. Oh, we already did that. Example 3. Use the following data sets. Compare the center of the two data sets. So we don't have the dot plots this time. We just have numbers. Okay. So we have Nature Trail A, daily visits, and we have Nature Trail B, daily visitors. So first step is to calculate the mean of Nature Trail A. Mean is the hard part. Mean is doing the math. So we're going to add all of these together and then divide by the number of add-ins. So we have 150, 180, 180, 250, 250, 300, 300. And then we have 1, 2, 3, 4, 5, 6, 7. So we have 1610 divided by 7 gives us 307. So Nature Trail A mean is 307. Okay. We erase all of the stuff that I did wrong because I did plenty. So use the dot. Wait, how did we end up with a dot plot? I think I'm clicking on the wrong stuff again. Okay, I screwed this up really bad, so let's see if I can fix it. The mean of Nature Trail A. Mean is the hard one. Mean is the math. So we have 150, 180, 180, 250, 250, 300, 300. And that's going to get divided by 1, 2, 3, 4, 5, 6, 7. And that gave me 307, which is not what they give on the next page. They give 230. But see, 307 really doesn't make sense because it's not in the middle of here. So how am I messing this up? This is twice that I've gotten this value. 1, 2, 3, 4, 5, 6, 7. How am I messing this up? Am I just typing it all wrong? 150 plus 180 plus 180 plus 250 plus 250 plus 300 plus 300. That's the number I keep getting divided by 7. Now it gave me 230. I have no idea what was going wrong. Apparently I'm just a moron, which is unsurprising. So the mean for trail A is 230. Now they want us to find the mean for trail B. So we need to take all of these numbers down here, which are not in ascending order. 350 plus 340 plus 230, 175, 190, 200, 210. That gives us 1695, and we have 1, 2, 3, 4, 5, 6, 7. We have 7 again. And that gives us 242.14. 242.14. Let's look and see here. Okay, that worked. So now calculate the median of each data set. So in order to do that, this one needs to be in ascending order. So we have 190, 200, 210, go away, 230. Oh, look, I missed 175. 175. Yep, you do that. 340. 350. Okay. So let's find the median for this one. Get rid of this one and this one, this one and this one, this one and this one. So 250 is our median there. Get rid of this one and this one, this one and this one, this one and this one. 210 is our median here. All right. Now let's go read our big long explanation. All right. Finally, analyze the results. Nature Trail B has a higher mean, showing that on average the number of visitors to this trail was greater. Using mean as the measure of center, it appears Nature Trail B has a greater center. However, Nature Trail A has a higher median. This indicates that half the values were above this point and half were below. Nature Trail A has a greater median in part because the data set is skewed left, while Nature Trail B's set is skewed right. Using the median as the measure of center indicates that Nature Trail A has the greater center. This example shows that while mean and median are both measures of center, they can give different information. Your turn. Question number 1. Using the dot plot, does the data set appear skewed? Compare median and mean of the data set. Go ahead and pause the video, do it, and come back. Okay, obviously it appears skewed because we have a dinosaur head that goes down to his tail. Okay, so let's do the median and the mean. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Half of 16 is 8. 1, 2, 3, 4, 5, 6, 7, 8. We need to take this and the next one because it's an even number. 1 plus 2 is 3, divided by 2 gives us 1.5. So the median is 1.5. Let's figure out the mean. Grab my calculator. I can skip all the zeros. 1 plus 1 plus 1 plus 2, 2, 2, 2, 3, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 26. Divided by 16 gives us 1.625. So the mean is 1.625. The data set appears skewed. The mean is 1.63, it rounded, and the median is 1.5. In this example, the mean is higher than the median. The data is skewed right because the few higher points are pulling the mean to the right. It's right skewed because the tail is on the right. Here's question number 2. Using the dot plot, does the data set appear skewed? Compare the median and mean of the data set in the dot plot. Pause the video, do it, come back. Yes, it's skewed because we have a dinosaur head going down to his tail. Let's find the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Half of 15 is 7.5. 1, 2, 3, 4, 5, 6, 7. We want right here. We'll take right there. So the median is 38. Let's find the mean. Grab my calculator. We're going to go 35. Ooh. 35 plus 36 plus 37, 37, 38, 38, 38, 38, 39, 39, 39, 40, ooh, 40, 40, 40. I'm fat fingering everything, so it's probably wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 38.27. So 38.27. The data set appears skewed because the observations are not symmetrical on the dot plot. The mean is 38.27 and the median is 38. The mean is slightly higher than the median. Here's question 3. The dot plots show customer data from an ice cream shop. Dataset A records the number of scoops ordered by each customer. Dataset B shows the number of toppings added. Find the mean of each dataset, then compare the mean of each dataset. Pause the video, do it, come back. Okay, they only want the mean this time, so we need to add everything together and then divide. So let's do the first one. We've got 1, 1, 1, 2, 2, 2, 2, 3, 3, 4, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is going to give us 2.1. Chunk, chunk, chunk. Let's do this one. We have 1, 1, 2, 2, 3, 3, 3, 4, 4, 4. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to give us 2.7. Tonk, tonk. Okay. So the mean of dataset A is 2.1. The mean of dataset B is 2.7. This indicates that the center of dataset B is at a higher point than the center of dataset A. This indicates that on average, customers added a higher number of toppings than the number of scoops ordered. And you can see that this one looks like it's pulling this way, while this one looks like it's pulling this way. Okay. Practice question number 2. Compare the mean and the median. Is the data symmetrical? Pause it, figure it out, come back. Well, we can work smarter, not harder. We can look at this and see it's not symmetric. On the ends, we have 2 and 3 already not symmetric. Now, if you want to see the math, you can stick around and watch it. Otherwise, you can skip to the next slide. The median for this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Half of 12 is 6. 1, 2, 3, 4, 5. Because it's even, we have to take 6 and the next one. So the median is 84. And let's find the mean. Add them all together. 80 plus 80, 81, 81, 83, 84, 84, 84, 84, 85, 85, 85. Gives us 996 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Gives us 83. You can see it's not symmetrical. Practice question 3. Sam has started a social media video channel. Sam is so excited about his new channel that he has been keeping track of his followers. He has created a dot plot for the first week of followers. Which statement about the dot plot is true? Option number 1, the data on the dot plot is skewed to the right. Option number 2, the data on the dot plot is skewed to the left. Speed round. Boo, 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 boo. Here is our dinosaur's head. Here is its tail. The tail is all that matters. So it is skewed to the left. Sometimes these are shuffled, so don't just pick number 2, actually read it. Here's quick check question number 2. Calculate the mean and median of the given data. Round your answers to the nearest half-hour increment as needed. The median is easy. You're going to find the halfway point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Half of 15 is 7.5. So you'll go to the number 8. And that will be your median, wherever dot 8 is. And then to find your mean, you will add these together. So this is going to be interesting because it's time. I'm going to pause this. Okay, I think I figured it out. What I would recommend doing is each of these gets added as a 5, so 5 plus 5. Each of these gets added as 5.5. Each of these gets added as a 6. Each of these gets added as a 6.5. Each of these gets added as a 7, and then you're going to divide by the number of dots. And then it's going to give you a weird decimal, and you're going to have to round it to the nearest hour. Okay? Let's talk about outliers a little bit. They are a number that is significantly higher or lower than the majority of the data set. So this is really useful for teachers when they're doing test scores, because sometimes you'll have a student that just didn't study, doesn't care, doesn't try in class at all. And if they score a 20% on the test and everybody else is scoring between 90 and 100, you really are a good teacher, even if that one kid scored a 20, right? You need to not be worried about the outlier. The outlier is going to pull your mean and median really low when it shouldn't be counted. It's not significant. The mean is heavily affected by outliers. Okay, this should be in your notes. It's the mean that gets affected. It's when you're doing the math, not just counting data points. This gets screwed up by outliers. The existence of outliers can eliminate the mean as an appropriate center of data. So if I have my test scores here and I have one kid that got 20, and then clear up here between 90 and 100, I have like 8,000 people. He doesn't matter, but he's going to screw up the mean because we're doing math. Okay. Here's example number 1. Use the dot plot to find the most appropriate center for the data. The dot plot is symmetrical. You can see that. Okay. You notice 0 and 4 have one data point, and 1 and 3 have 2 data points. They mirror each other. In this example, the mean is 2, so the median is also going to be 2. They match. When you compare the mean and median, you will find that they are equal. In this example, the numbers are not affected by any outliers. There's nothing weird going on here. When you have data that is not affected by an outlier, the best center to use is the mean. So no outliers, use the mean. Mean is widely accepted as the most specific average. When working with symmetrical data, the best center is the mean. This needs to go in your notes. Here's example number 2. Use the dot plot to find the most appropriate center for this data. In this example, all the data is skewed to the left. Okay, you can see we have 5 points up here between 3 and 4, and then 3 down here that are real low. These are outliers. These are not significant when you look at the dot plot, but they're going to screw up the mean really bad. Okay, they're going to be weighted really heavy when they shouldn't be. Most of the data lies on the higher end of the scale, and there's a tail to the left. In this data set, the median is 3 and the mean is 2.625. When you compare the two, you find that the median is higher. The reason that the median is higher is because the mean is affected by outliers. In this example, the mean is affected by significantly lower data points, and so it cannot mirror the median. Since the mean is affected by low data points that are not consistent with the rest of the distribution, the mean is not a good choice for the center. This trend will hold true for data that is skewed in one direction or the other. So when you have skewed data, you want to use the median. Skewed is good for the median. This should be in your notes too. Okay, skewed equals median, because you're more likely to get an accurate center. Okay, here's question 1. This is all you. In the dot plot, which center is the most appropriate and why? Speed round. Boo, 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 boo. Obviously, this is skewed data. It has a tail. That means that the best option is going to be the median. Okay? Median. The median is the most appropriate because the mean would be significantly affected by the presence of an outlier. This one is strange. Only one person took 4 electives. That's not normal. Most people took 0. Okay? Question number 2. In the dot plot, which center is the most appropriate and why? Speed round, blah, 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 blah. For this one, it's going to be the mean because it's the most specific and this is symmetrical. Okay? The mean would be the best measure of center because it is not affected by an outlier. There's nothing weird going on in the graph. Okay, practice question number 4. A group of students created a dot plot of their heights. Based on the dot plot, find the mean and median height of the students in the class to show that the two measures are different in this skewed data set. Round your answers to the nearest tenth. Okay, so let's start with the mean. They want the mean first. So let's add all of this garbage together. Are we so excited? 4 plus 4.25. 4.25, 4.25, 4.25, 4.25, 4.25, 4.25, 4.25, 4.5, 4.5, 4.5, 4.5, 4.5, 4.5, 4.75, 4.7, I did that wrong, 0.75, 5, 5, 5, 5.25, 5.5. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, divided by 22 gives us 4.55. So we're going to say 4.6. 4.6. These must be young students. That's not very tall. Okay. And then the median, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22. Half is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That and the next one. So the median height is 4.5. Because this is skewed, this is going to be the most accurate one. It didn't ask that, but 4.5 is going to be the most accurate center. Here's practice question number 5. Which data distribution is the most symmetrical and suggests using the mean as the most appropriate measure of center? Speed round. Boo, 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 boo. Well, obviously this one's the most symmetrical. It still has a tail, but it's the most symmetrical. This one is very skewed. Okay, so second period. Remember, these might be shuffled. Don't just pick number 2. Here's quick check question number 3. When comparing the means and medians of skewed data, which of the following is correct? Okay, so you have to go through and figure this out. We're looking at skewed data. So the mean and median differ. The mean and median are very close together. The mean and median differ. The mean is always less than the median. So that's the first half. The second half is based on the direction and amount of the skew, not affected by the skew, because of the direction and amount of the skew, regardless of the direction and amount of skew. You can do this. Okay. Quick check question 4. A team of students were comparing the mean and median of a dot plot and noticed that the dots made a graph. They labeled the mean, median, minimum, and maximum of the graph. Which point is most likely the mean of the skewed data? Mean is what you're looking for. Okay. What I would do here is I would eliminate the minimum and the maximum because those are easy to identify, and then figure out which you think is the median and which you think is the mean. With skewed data like this, it obviously has a tail. The most accurate one is going to be the median. Okay, the mean is going to get pulled towards the skew. Quick check question 5. Explain how the shape of a distribution determines the appropriate measure of center. So which of these is accurate? Skewed data means that the mean is the best measure of center. The shape does not matter when determining the appropriate measure of center. More information is needed to determine how the data of distribution determines the appropriate measure of center. Symmetrical data means that the mean is the best measure of center. Okay. And Canva would come up with such gems for SpongeBob. What is this nastiness? This fish looks like it's on drugs. Octopuses are just the weirdest thing in the world. And a cactus? What does a cactus have to do with SpongeBob?